Hello boys and girls, so in this video we continue our discussion on topic 3. So we have 3.3, the variation of resistance with temperature. Before this we already learned about how we produce current in a conductor, and then the opposition to the current flow is what we call resistance. So today we are going to see the dependence of resistance with temperature. So what are going to happen to the resistance when temperature increase? So class, so we will find that the resistivity rho of a conductor will increases with the increasing of temperature. Okay, so the resistivity of a conductor will increases with the increasing of temperature. So for example, this is our conductor. So in conductor we have atoms and we have a lot of free electrons. Okay, so as the electron drift in a specific directions inside the conductor, we will get what we call current. So why the resistivity of the conductor will increase when temperature increase? For example, when I heat up the conductor, bila saya panaskan conductor ni, macam mana dia boleh menjadikan resistivity of the conductor increase? So when we heat up the conductor, we will find out that the atoms will vibrate more rapidly and over a longer distance at higher temperature. So all these atoms will vibrate. They will start to vibrate up and down. For example, they will vibrate. So dia akan buat vibration. Dia akan gerak atas bawah. Okay, so all the atoms will vibrate up and down. Alright, they will start to vibrate over a larger distance. So as the atom vibrate over a larger distance at higher temperature, we will find out that it will be harder for the free electron to move, to drift through the conductor. So the free electron that moving through the metal, or we call it as conductor, will, okay, so the metal here actually refer to the conductor because only metal can conduct current, right? So the conductor will make more collision. So we will find out that at high temperature, the free electron that move through the metal will make more collisions. So as the electron try to move in order to produce current, okay, in order to produce current, as this electron try to move through, it might collide with the atom that vibrate eagerly. So this will embed the drift of the electron. So ini akan melambatkan pergerakan electron. So the collision will slow down the movement of the electron. So when it slow down the drift or the movement of the electron, then we will find out that the resistivity will increases. Okay, the resistivity will increases. So this is the reason why when temperature increase, the resistivity of the conductor will increase. Clear? Okay, so if I sketch graph resistivity of the conductor against temperature, so I will find out that as our temperature increase, the resistivity increase. Okay, as our temperature increase, the resistivity of a conductor will increase. So we might want to find the final resistivity after we increase the temperature over a certain range. So let's say I denote by a reference temperature is T0. So kalau certain suhu ni, pada certain suhu rujukan reference temperature T0, our resistivity of the conductor saya denote sebagai rho naught. Okay, so as the temperature increase, so our resistivity increase. So maybe we would like to find, okay, when my temperature increase to T, what is the value of the resistivity at temperature T? So how I'm going to find the resistivity at temperature T? We can relate with the reference resistivity at reference temperature, whereby we have this equation. So kita boleh relatekan semua ni gunakan equation. The resistivity at temperature T is given by the resistivity at reference temperature rho naught in bracket 1 plus alpha T final, the final temperature, minus the reference temperature T naught. Okay, so this value sometimes is also, we call it as the change in temperature. Okay, so when the temperature increase, we have change in temperature. When temperature increase, our resistivity increase. So what is the final value of resistivity at temperature T? We can calculate using this equation. Okay, kita boleh kira gunakan equation ni. And then class, if you recall from the previous lesson, we can relate the resistivity with resistance. Resistance is resistivity multiplied the length of the conductor over the cross-sectional area of the conductor. So, if I put it in this equation, so the final resistivity will be RA over L. Teacher rearrange this equation now. Teacher rearrange this one. I'll get the resistivity is RA over L lah. Betul? Right. So I put it in. Okay. So the resistivity at reference temperature will be, the resistivity at reference temperature will relate with the resistance at the reference temperature lah. R naught area over L, then in bracket 1 plus alpha T minus T naught. So we assume that when we heat up the conductor, the area and the length of the conductor is constant. It doesn't change. Do not change. Okay. So if we assume A and L do not change, means that I can cancel out the A and L lah. So A and L can cancel. Then I'll get the resistance at final temperature after we heat up will equal to R naught, the resistance at reference temperature, in bracket 1 plus alpha T minus T naught. Okay, so this is another equation that we can use. So we can use this equation to find the final resistance at temperature T after we heat up the conductor, providing that we must know the resistance at reference temperature. So resistance at reference temperature I denote by R naught. T naught is the reference temperature. So I write it down. This is the resistance at temperature T. This is the resistance at temperature T naught, reference temperature at reference temperature. Okay, so T is the temperature where we have already heat up the conductor. T naught is the reference temperature. Okay. Normally the reference temperature is the room temperature Normally the reference temperature is around 25 degrees Celsius or room temperature. Okay, normally the reference temperature is 25 degrees Celsius or room temperature. So what is alpha? What is alpha? Yeah, what is this term represent? Alpha. What is this term represent? So the alpha is what we call the temperature coefficients of resistivity. Okay, alpha is what we call temperature coefficients of resistivity. Different material will has different value of alpha. So you no need to memorize. You might refer back to your lecture notes, whereby I give you example in your lecture notes. The various material will have various value of alpha. For example, silver, the value of alpha is 4.1 to the power of -3 Kelvin per Kelvin, or mercury, the alpha is 0.89 to the power of -3 per Kelvin. Alright, so this is the equation we use when we to see the variations of resistance with temperature. Okay, if you want to find for the resistance, you use this equation. If you want to find for resistivity, then you might use this one. So which one you want to use? It depends. You want to find the resistance or resistivity. So you might refer to your tutorial question 3. You might refer to your tutorial question 3. So we see how we are going to apply the concept we learned just now. So we have the resistance of a tungsten filament of a bulb at 30 degrees Celsius is 1.15 ohm. So the question tells you the resistance of a filament in a light bulb at 30 degrees Celsius is 1.15 ohm. Under normal operating conditions, the current in the filament is 0.3 ampere when the voltage is 3 volt is maintained across the bulb. If the temperature or coefficients of tungsten is 4.5 to the power of -3, what is the working temperature of the bulb? What is meant by working temperature? Working temperature means when the bulb is lighting up lah, is light up. Okay, bila dia menyala, then itu maksudnya dia working lah, sebab the main purpose of a bulb is keluarkan cahaya, right? It will light up. So let's say this is the filament, so this is the light bulb. So the question tells us that the resistance of this filament is 1.15 ohm at temperature 30 degrees Celsius. And then, so how we are going to light up the bulb? Working, when the bulb is working means it light up. Okay, bila dia bernyala means dia mesti sambung kepada voltage lah. So kita sambungkan kepada voltage 3 volt, current akan flow. So current yang flow ialah 0.3. Dan waktu tu light bulb ni berfungsi lah, operate or working. Okay, so we want to find the temperature of the working bulb, working temperature of the light bulb. So kita nak cari berapa temperature dia dekat sini. So this one will be our reference temperature. So this one will be our reference. So since this one is our reference, so this one will be our naught. The 30 degrees Celsius will be our reference temperature lah. So we want to find the final temperature whereby the light bulb is working. So how we are going to relate the final temperature with the initial temperature? We know that when the light bulb is operating or working, is heating up. Dia jadi panas kan? Lampu mentol yang bernyala tu dia panas, filament ni panas, barulah dia boleh nyalakan lampu tu. So this one means our resistance must increase lah. So kita tahu kita akan guna R equal to R naught in bracket 1 plus alpha T minus T naught. So I need to find the resistance at that particular working temperature. So how I'm going to find the resistance at that particular working temperature? So since I know about the voltage and also the current, so I might calculate this resistance first. I can calculate this resistance using the Ohms law. So I use Ohm law, I find the resistance at the working temperature. So the resistance will be the voltage 3 volt over 0.3. So I'll get 10 ohm. Am I right? 3 over 0.3 is 10 ohm. So I put it here, 10. The reference resistance is 1.15. So in bracket 1 plus alpha. Alpha is the temperature coefficient of resistance. So it's given 4.5 to the power of negative 3. So I put it in 4.5 to the power of negative 3. Then I have the working temperature that I will need to determine. The reference temperature is 30 degrees Celsius. So I put it in. Then I'll start to solve the question using the correct mathematics skill. So you might pause the video to calculate the value for the working temperature. So I move 1.15 to another side. It will become 10 over 1.15. I get 8.6957. So another side I'm going to have 1 plus. So I multiply in the value. So I get 4.5 to the power of negative 3t minus 0.135. So then it will become a more simple mathematics for you to solve. So solve it, you will get the operating temperature or the working temperature. So if you calculate correctly, you will get the value should be 1740.14 degrees Celsius. Okay, so this is how we apply the concept. So as our temperature increase, so you can see obviously when our temperature is high, our resistance is greater, 10 ohm, compared to the reference temperature 30 degrees Celsius, our resistance only 1.15 ohm.